So thanks a lot to be here. My name is Paula. Actually, I'm from IBM Research, the lab that we have inside IBM. So I'm a research, data science, and also a master inventor there. And I'll talk a little bit over a project that we have that we use a graph to analyze data. So just to have you an idea, so IBM has 12 labs overwide in 10 countries. We are the 8th lab to be open here. We were opened in 2011. So the lab is pretty new, is 6 years. So before the lab, I was a professor at the Federal of Espírito Santo. We have more than 3,000 research over the world. Here in Brazil, we were a little bit more than 100 persons from several areas. So we used to show the picture of our lab in real because it's much beautiful than the view here from 23 de Maio. So just to have an idea. But let's move to the project. So the project that we have was a 3-month project from a health insurance company that gave us data and tell us, oh, I will give a bunch of data. Let's see what you can show to me that I don't know about this data. And this data was more or less, this data was most about claim data. And we have medical attention transactional data. It was nationwide, spanning 1.5 years. And we have 0.6 terabytes compressed. So, and what we have in the data? We have information about physicians, patients, healthcare providers, claims, health insurance company, and health insurance service, exams, consultations, and other things. We have more than 40 tables. The claim table used to have more than 80 extra rows, so we have a lot of data. And just for you to have an idea, we spend like almost 1 month to understand the data, and to open the database, you have several problems. And the table that was paid claims, you have more than 109 million tuples. We have more or less 220,000 physicians, 2.2 million patients, and the per physicians patient, we have 11.6 million. And we have other data. So what's the problem? Well, no, we in the first meeting with the, sorry for that. We have the meeting with the client, so what's the problem you were trying to us to solve? They want to understand the physician, but the whole system, the claim data paid, the health insurance, is just about the providers. And the providers could be clinics, could be hospitals, and the clinics could have 1 or more physicians that work in the clinics. So the whole system of payments and transactions are about the providers. And they want to know about the physicians that are implicit there. And what they want to know actually was pretty funny. They say, oh, we want to know what are the good and the bad doctors. I say, okay, but what good and bad means? We don't know. So actually, they want to understand the relationship among the physicians. So how the patients flow and how they could characterize the physician, even if the system is about the provider. So what was the idea here? So since day one, they want to discover the relationship between physicians, we start to work in a network approach. So we use the claim data table, that was the large table and the one that has more statistical significance, and we start to build a network. So just to remember, a network, a complex network, is modeled as a graph. And in a graph, you have nodes and edges. And then we can have a weighted graph or bipartite graph or direct graph. So we create a graph, physician-patient, with 2.24 million nodes and 11.6 million edge. We keep the largest connect component that was between 92 to 99% of all links. And we remove multiple edges and map to weights. So this is more or less an example. And then with this network, because they want to know just about the physicians, we transform this network to a network physician-physician, where two physicians are connected if they have a patient in common. And for this, we use just the service of consultation. We ignore exams and operations, surgeries, and other things. So the first thing that we did with our network was the degree distribution. And why that? Because in most social network problems, if your network is a scale-free network, they have some properties. If not, if it's a edge-range network, that's usually a random network, they have different problems. And when we map this, he's in a log-link scale, but if you plot in a log-log scale, you will see that we will have a power law. And if we have a power law, we can apply all the methods and abstract to the characteristic of a real social network. So, and also we have some conclusion. For example, in this physician distribution here, we have one physician with 30,000 patients in 1.5 years. What's very surprise for us. So if you make an account, he will attend a patient every 80 minutes over 24/7. So he didn't stop. So it's very spurious. And also you have a patient that went to 123 different physicians over 1.5 years. Oh, they have a very serious problem. This patient, I don't know if he is not live, or there is some case of outlier here, and the health insurance company needs to look that. And also you have some things like, we have like a lot of physicians that attend just one patient over the years, so we could be some problems with new doctors come to the health insurance system, and they need to look close. So the idea here is to use this network and create metrics. So actually we use some state-of-art work, but also we develop some metrics to characterize these physicians. And the idea is to build a feature vector of each physician, and then the health insurance company will label this feature vector saying, oh, this is a compliance doctor, this is not a compliance doctor, and then you can build a machine learning, a classifier, or filter, or reduce, or do something approach with the physicians based on this label. We create some metrics, but the three that I will highlight here is the mutual reference, the loyalty, and the centrality. So our case is to build metrics for describe physicians using complex network. So just to have an idea, this is the plot to our physician network. So we have the degree, the size of the dots is the degree. So if you look, this is a very nice visualization, but you cannot extract anything from there, but it's very close to a friendship network. So the first metric that we built was trying to identify strong connections between each pair of physicians, in particular the outliers. So how we will build this? We have the patients and the doctors, and we create a networking using the timestamp of the consultations. So when the patient 1 went to the physician A, and then went to the physician B, we create a link between A to B. And then we go back to A in another day after we create another link. Could be the same patient, it could be another patient. The weight of the link could be several times the same patient, but what is important is they need to go to A and then another day after B. Not could be 10 days or more. And then we have here the weight, a number of patients, and also the average of the days between two consultations. And the difference between A to B and B to A should be more or less, that should be very small. So the weight of the edge should be more or less the same. And then we have more or less this distribution over the 5 states of Brazil. So here we can see that in states like Bahia, Distrito Federal, and Pernambuco, the distribution is very similar. The density of the top 20 and the top 15 is almost the same. So this means that we have a large group of doctors that is very well connected, and most of patients go to these doctors, and we have like a strength of the relationships. Here we have like a pair, and this I have another that's very connected. And the distribution is different for Rio and São Paulo. We can see that in Rio and São Paulo we have very big guys that attract most of the patients, and we have very large connections. For example, here, these two guys, actually these three guys work very nice together. So this could be because the health insurance company has more representativeness in São Paulo and Rio de Janeiro and less offering in other states. And also in São Paulo and Rio, we have a different behavior because people try to go to a very top guy. They work very together with other doctors, and we have more for regions. So they could explain a lot of things. And here are some other visualizations that we built. So this is a tool that we build, and then I'm showing the ends. And you can see that if you look closer for the specialist, here's, for example, is an allergy. This guy is an allergologist, and these two, and is connected with other other doctors. So he has a very important guy and has a lot of connections. If you look, for example, for ophthalmology, he has a different behavior to work. So he is not a very specialist guy. So you go to an ophthalmologist, and if you need something more different, they indicate to another guy. And you work more or less in pairs. So you have several pairs that has strong connections. So we have some insights about this. So we rank these, and we also have normalized metrics between 1 and 0 about the pairs of the doctors. And interesting case, we have this pair from Mato Grosso do Sul that he has a weight of 205 and 196 in a year and a half. This could be a very strong connection. This guy worked very well together, or it could be something suspicious. For example, these two guys in Distrito Federal that has a weight, a very large weight, but the average of this equal to 0. So most of the patients go to the both doctor in the same day. What's very strange. So this metric is an indicative of potential relationship of physicians, and if you spot like fraud or some good relationships, because if both physicians or more than one works very well together, and the health insurance company need to reduce the number of physicians or do some actions, they need to look to this relationship, because if they do some actions for one guy, they need to do for all the network of that guy. Or if they lost that guy, this will affect a lot of patients because this guy is very connected with other physicians. Patient loyalty. So here, what we want to look is how the patients are going back to the doctor. So this is important for chronic diseases. We have like just 1 year and a half. It would be good if you have more time, like 5 or 10 years. But what we did here, we divide the data by quartile and try to analyze if the doctors continue in the same in the top or not. So here first we consider patients who visit many doctors. So here we have the patient and the timeline. And then we compute the relative weight for each doctor visit. So we have more or less this distribution. So this is the doctor of this patient that he most visits. Of course, if you have just one tuple of the patient in the database, does 100%, but the degree is 1, so he went to just one doctor. So it is not important, but he have like 10 claims in the database and he went to 50% of the time in one doctor, this counts more, okay? And then we create this metric, what we call diluted and concentrate. So we use like the strength. So if the degree is equal to the strength of the edge, is not very significant, but these are the cases that were most interesting. And then we plot the network. So these guys over here are the more important. So they have a large degree. They went to a lot of physicians, and they went more in one physician. So they have the strength. And then we compute this for each physicians. So we get for each patient what was the most important physician, the physician that you went more, and compute this metric for each physician, and then we normalize to create a rank and also to normalize the distributions, because this is alone. So here we have physicians that have more and others that almost does not appear. So in most of the case, what appeared was the orthopedic and traumatology was the most recurrence doctor. Of course, if you broke your leg or if you do something. We have also pediatrician, gynecologist, and obstetrician, and ophthalmologist. And these, of course, if this metric can be applied in a large time, probably the results will be better. A given doctor in the rank 1 or 2 doing the all quartiles, and we have more or less 20% mean turnover across the quartiles. We also look the centrality. So in our network, we apply the centrality metric. We use 4 different centralities: the eigenvalue, the degree, the betweens, and the closeness. And even this metric is not being equal or have the same meaning, they keep stable. So what was the top in one was the top in another metric too. And this is important to also to understand the relation of the doctor with other physicians, because a guy that has a high centrality is very important to the network. So we have cases that the health insurance company wants to build a network of physicians with less physicians. So how they choose the physicians, how they need to choose to build a small network that will attend the patients. So this is very important. And also they have like physician in the periphery with a very low centrality that you should do some actions to incorporate, to attract, and to give a better results. Otherwise, there's no meaning to be in the company. So a summary. So in a large healthcare claim database from a Brazilian insurance company, we apply complex network methods to find how physicians building their network. We use like temporality, reciprocity, and loyalty. Networks are about a relationship, so if you have a problem that you need to understand the relationship between things, objects, this is the case. And complex network is available is a value tool to data science that not always use it, but it's very important. Some reference for if you don't know about the subject, just to be marked in the last book, Handbook of Big Data Technologies. I have 2 book chapters wrote here, one about graph, a very nice survey. And also we have several platforms today for graphs, not only IBM, but a lot of open APIs. So we have like database for graphs, we have APIs, and also we have a nice tool for visualizations. And that's it. I will show a quick demo here. So this was the tool. Let me put in a full screen. This was the tool that we built over the 2 metrics, the mutual reference and also the loyalty that here is retention. So the colors of the nodes means the retention. So the dark ones are with more retentions here. Here is the pair of Mato Grosso do Sul. So, and also we can see what I was telling you. So if you go, for example, to cardiologist, we will see that we have like a big guy here connect with several other doctors. So specialty was a very difficult thing because a physician could have more than one specialty, but in the health insurance company, they are registered with just one. And we have just 30% of specialty in the database, most are empty. So in this project was very challenging because we can see in the practice that 80% of our time is to cleaning and pre-process the data, because we got the data that you don't know about, so you need to be in contact with the specialist, in our case a focal point in the health insurance company. In the claim data we have like 3 CRM, and we have a lot of different timestamps, so we didn't know how we should use. Our luck is that IBM is a very big company, so you always find someone that understands and can help in problems. So Daniel's the end, he helped us a lot in this project with the data. And if you look, for example, to ophthalmologist, you see that you have a different behavior here. And we have some metrics here. So we have some the degree distribution of this plot, and we also could select. So we build things using the platform of services of IBM, the Blue Mix. In this case, we use JSON. It's a Cloudant database, because in that time we built this. We didn't have the database for graph. Now we have the IBM graph. And also here we can see, oops, I don't know if you, we have the visualization of the whole network. And here we can explore by state and other stuff here too. So that's it. Thank you.
Thank you, Anna. We have questions.
Hi. Thanks for the talk. You said something that was very interesting. Data scientists are not using graphs as much as we think that they should use. Why is that in your opinion? So why data scientists are not using graph techniques more often?
Well, I think there is a vibe about machine learning, deep learning. So I recently also create a blog because, you know, everybody thinks that deep learning will solve all the problems of the world. And I think that's not true. So if you get some statistics, of course, that machine learning classification will solve like 75% of all problems. So if you know classification, you are good. So now people are trying to learn about deep learning and so on. So I think the vibe of the graphs are down because if you get like 5 years ago, it's all about social networks and Twitter and how to model and the links. And now it's not that. And also we have a very big problem because it's not easy to put a graph in a deep learning. So this map, how you get the properties of a network and train a machine learning to solve problems of graph is not solved. It's a very open problem. And I think it's a lack of knowledge, because when you say graphs, most of computer science think about graph theory, and the algorithms are very expensive, and graph mining is not this. So I get a lot of content of some people, oh, I want to know about apply Dijkstra, and say, okay, so for a large graph, you will not use this kind of method. There is other methods. That's not exactly, but it will run in a very nice time. I think this was one of the first projects of IBM in graph. Actually now in IBM here, everybody, oh, this you are Ana Paula from graphs. I say, okay, so I got a title, but I think that I think there is tendency of everybody saying about deep learning because the large data and lack of knowledge about this. So in my point of view, in data science, there is a lack of knowledge in this case of this unicorn, because you have so much techniques and so many ways that you can solve the same problem, for statistics to graphs to other techniques that people forgot. This is why it's important you have a very diverse team, because you have different, so here we have a HCI person for the visualizations, because I'm crap on visualizations. We have a physician, a physicist to work with us, and me. And also we have a person that's in the medical thing, so she has computer science background, but also is a physician, to work to also to understand this. And when they say, oh, we want to understand about the relation, you say, okay, this is a graph problem. And sometimes people forget this. For in your previous talk, when you say relationship about a user and content, you also can map this a graph. Metrics factorization is very useful in graph problems. So we have other things to say. So when you say clustering, you could apply a community detection instead of that. So sometimes this lack of knowledge, it's affect the problems.
Sorry, just a quick follow-up. So are you aware of any work in using graphs to make predictions as well then?
So I know that IBM has a use case from Yorktown using graph, for example, to predict fraud, to avoid when you pass your credit card and it's denied, but it's okay, it's you. So they are using graph metrics. They are mapped the transactions, the bank transactions, to avoid these. So they are using like PageRank or something like that. So I know, for example, big companies are using, for example, we have like work that to infer new rules for example, Freebase. So using random walk, and people from CMU also are using this. And now, of course, we have like Pinterest and other companies, big companies using this. And I know that also there is other projects going on, especially for fraud, something using graphs.
Hi, Paula. Congratulations for your work.
Thank you.
And
Thank you.
regarding to the problem, doctor-patients here. So we know in Brazil we have some doctors have contracts with health plans that should work exclusively for that kind of health plan, which leads to some patients work and go to some doctors, specific doctors. I wonder if this kind of behavior can influence the graph analysis. So what do you think?
Yes, of course. If you get this mutual reference, the idea is to map this. So you get the doctor that's close related, because if you get that distribution in the northeast of the country, probably is this, because you have a very small number of doctors of this health insurance company, and the patients, if they don't go in these physicians, you need to pay. And sometimes your health insurance doesn't allow you to get a reimburse, or you prefer to go because of the reimburse, and so on. But you also have some cases that look like a fraud. For example, you go in a physician, and then you pay for 2 consultations. You go to the one and you pay for 2 because, or the exam you need to do with the other guy, or because they recommend just to get more money. So we have some of this case.
Okay, so for further questions, please approach Anna during the coffee break. And with this last presentation, we close this session. We have 2 more sessions later. I hope you all going to watch the next sessions. So we are all hungry now, and we have all some coffee break waiting for us. Thank you.